Hey folks, have you started on a new project or are you ramping back up after the holiday season? The January Marketplace sale can help, featuring more than 1,000 products on sale now through January 16th. And if you earned the $10 coupon from the Black Friday sale, your coupon is now activated and available for use until January 31st. From props to characters, environments to music, and so much more, start exploring the UE Marketplace now. More than 16 years after the release of the original Psychonauts, Double Fine Productions returned to the series with Psychonauts 2 last year. Made up of former LucasArts employees, Double Fine's debut game was also an introduction for many to creative director Tim Schafer's wit. That same wit attracted similarly minded devs to Double Fine and helped the studio bring some of the most unique projects in the video game industry to life. Watch our spotlight on the Unreal Engine feed where Double Fine shares how it created its critically acclaimed mind-bending ride. Reshape in-vehicle displays with Unreal Engine and get your work seen by some of the most innovative automotive companies in the world in the Unreal Engine HMI Design Challenge, created in partnership with Car Design News. If you can make a driver feel adventurous, luxurious, or sporty with 3D graphics, you just might win. The competition runs from January 26th through April 1st. Get the full details on the feed. With well over 50 Unreal Engine-powered games set to launch in 2022, this year is primed to be one of the biggest years for UE developers around the world. To commemorate the wide array of highly anticipated games, which include action-adventure games, fighting games, RPGs, VR titles, and much more, we've put together a snazzy sizzle. Check out the full reel and get more info on a selection of these games on the blog. And on over to our community spotlights, spinning off from their in-production animated feature film of the same name, Hazamation has recently announced Rift, a third-person arcade-style shooter where you attempt to sneak and shoot your way out of a research facility as a boy with psychokinetic abilities. Both the film and game are being simultaneously developed in Unreal Engine. Keep up with these exciting projects at hazamation.com. Next up, Poland-based dev team Far From Home unveiled Project Oxygen as Forever Skies, their first-person action survival game. Return to an Earth destroyed by an ecological disaster, fly a custom-built high-tech airship, and face the dangers of the surface as you hunt for viral pathogens to cure a mysterious illness. Wishlist Forever Skies on Steam today. And last up, Tales of Forgotten Heroes Alchemist from ER Studios. In the fast-paced, open-world action RPG, you'll take control of 4 legendary heroes in a land known as the Realm of Eternity. Journey through the fantastical realm and uncover the secrets of the Alchemist. Stay up to date and join their community via tofhs.com. Thanks for watching this week's news and community spotlight. Hi, and welcome to Inside Unreal, a weekly show where we learn, explore, and celebrate everything Unreal. I'm your host, Amanda, and I'm really excited to welcome our guests today. We have Richard, the RTX Unreal Engine evangelist from NVIDIA.
Hi.
We have
How's it going?
we have Homam, a technical artist at NVIDIA.
Hey, how was?
And I am absolutely thrilled to introduce Tina, the latest community manager to the Unreal Engine team, who is going to be joining and eventually be hosting these shows. So I hope you all give her a warm welcome in chat and tell us a little bit about yourself, Tina.
Sure. Hi, everybody. A little bit about myself. I was a 3D artist and developer for about 6 years. And then I was actually a professor at Folsom University for 2 years, where I taught how to make environments in Unreal Engine, actually. So here I am now. I'm here and excited and really, really happy to take on this adventure and help out the community and be here with you guys.
And when not gaming, she's also a big tabletop fan. So if you want to talk D&D,
Yes.
she's your gal.
Please do. Please do.
Yeah, so we're excited to have you. Again, welcome everybody. Richard and Hamam, thank you so much for joining today. We're going to be talking about RTX
global illumination, the plugin, and then the RTX direct illumination technology that you're building out. So excited to hear more about that.
Cool. Yeah.
Yeah.
Should I just start with the plugin itself? Should we go there?
Sure. Or you want to tell us a little bit about what you're doing at NVIDIA? Or what you two do at NVIDIA?
Yeah, well, so I'm the ray tracing Unreal Engine evangelist at NVIDIA. My background is in game design and game art. So I've worked for a number of studios, Electronic Arts. I worked for Gearbox for a while, helped with the Borderlands series, helped on Battlefield. So I've been doing this for a little while. I suspect Hamam is going to have a similar set of stories or description about himself.
Yeah, very close.
But yeah, that's basically it for me as far as that. My job really is just to help developers understand the technology that we're making.
Cool. Yeah, similar experience. I think I have more than 20 years of experience, but it's more focused on AAA game development on consoles. I recently decided to switch a bit in my career and focus more on working on the technology behind games. So I joined Epic like 5 or 6 years ago. I spent very good 5 years, and now I joined NVIDIA as a technical artist. And as any technical artist, I work a lot with blueprints, with materials, sometimes create content, and so on. So really interesting.
Awesome. So we've got some cool scenes to show off today, right?
Yep.
Yeah. Yeah, we can start with RTX GI. Actually, maybe just start with a description of what global illumination is, just to make sure everybody really understands what we're talking about. So yeah, the global illumination is sort of the result of what happens when a light source strikes a surface, and that surface, based on its value and its energy and so on, creates indirect lighting or bounce lighting. At a very high level, that's what global illumination, or GI for short, is. And RTX GI specifically is a ray tracing version of that. It allows us to do GI in real time with no light baking, and with very good quality and very high performance. I think you guys can see my screen here. I can show you specifically in RTX GI in the context of the plugin and the technology, how this works. RTX GI is a probe-based technology. So wherever you want your GI to operate and be, you place down volumes. And I can visualize what that looks like. Within the volume, there's a series of probe points. And this whole setup of probes and volumes is very similar to light mass importance volumes, right? Where there's sort of an array of probes within the volume that determine how lighting should be applied back into the world. And that's exactly what's going on here. So we're using ray tracing and firing GI rays from each probe point in the volume, and generating a texture, an octahedral texture map at that location, and then reprojecting it back into the world. So that means that it's projected in world space, right? The GI won't disappear like a screen space effect would, like if I get close to a surface, like I come over here and the GI vanishes on me and stuff like that. It remains in place, no matter how you look at the world. And like I was saying, it's fully dynamic. So if I just do a quick play in editor here, you can see how the bounce lighting, all that indirect lighting is generated, and it's very soft and sort of natural, more like what you'd expect. So it's absorbing the color value of the surface and bouncing those light rays around in the scene, and doing it very quickly and efficiently, and without you won't see any noise patterns or any of those sorts of issues that you might typically expect from like a low sampled ray traced scene. So like this gets to all the high level points of RTX GI, right? High performance, high quality, and using ray tracing and probes as a backbone, it does what it does very quick and very efficiently. So yeah, that's a high level overview of the technology. Any questions at this point? What do you think, Amanda?
So they've had some general questions about RTX and how it interacts. So like,
Yeah.
Michael was asking, do you need to bake or build GI even if you use RTX? If you use ray tracing, do you need to do any of that?
Right. The answer is no. The technology is intended to be fully dynamic and real time, so there's no light baking at all. The GI, builds in front of you, within milliseconds, really. So it you can. There's a lot of interesting topics there, though, because RTX GI is able to store what you see on screen in a static mode and have that display on non-ray tracing hardware, right, or lower end systems. And the static mode also no baking times, right? It's this. I mean, we'll get into it as we go through this presentation, but it's as simple as simply grabbing your GI volume and saying runtime static and flagging that. I'm using, so everybody knows, I'm using 427 and the RTX GI plugin right now, the currently released version. In the future, we're going to have a version of this where the runtime static field is a drop-down menu that allows you to be either static or dynamic, and as a third option, fall back to static on non-ray tracing hardware. So, giving even greater compatibility to non-ray tracing systems. All you need is ray tracing hardware to author it on, and then anybody can see the results of RTX GI.
Awesome. I think it'd be helpful for us to dive in a little bit, and then we can pull in some of these questions afterwards.
Sure. Okay. So, I mean, that's a very high level of the technology. Like I said, there are these volumes that you place. We call them DDGI volumes, and you can see there's a number of settings. But as we go through this, I'll help to explain this. It's also worth noting that we put out a series of videos on our YouTube channel. There's a playlist of like 5 or 6 videos that step through how to set this up and what all the different settings do and different ways you can optimize for it and get even better performance out of it, or higher quality. So there's a number of options there and a number of fine-tuning controls. So I don't think we're going to go through every single one of those details here, but I want to make sure people are aware that those videos exist, and we'll cover a lot of information here for sure. I do want to show, I think, how you install the plugin, because it's a little bit different than how you'd normally install something through the marketplace. We do have a page on the marketplace, but you have to do because of the NVIDIA end user license agreement, you have to click through our website in order to download the plugin and then manually install it. So it is an extra step, but I just want to make sure that people understand that that's there, and it's not too difficult. If you've installed the DLSS plugin, it's the same process. So I'll just show you exactly how that works. If you go to the marketplace, the front end, and search for RTX GI, right? Here's the link to it, and you'll notice that it says external link for the plugin. So when I click that, it'll pop up into my web browser. right. And it should take you right away to the download section on the web page. And you would need to agree to the terms of service, and then you have a direct link to the download the zip file. So yeah, I would pull that down. Right.
And is this 427 specifically, or do you have support for older versions?
Yes. The plugin is the standalone plugin only works with 427, and that's because we needed to have in order to get the binary plugin to work in a standalone fashion, we had to have certain engine side changes in Unreal in order to support that. So we do have a version for there's older code for 426, for example, but it requires an engine change. We have our own branch of Unreal 4 called NVRTX, the NVIDIA RTX branch. It's just all the same code. It's just an optimized version of the ray tracing side of it. And
okay.
Yeah, and if we maintain like 425, 426, 427 versions of NVRTX. So if somebody wanted to get that older version of RTXGI, the non-binary version, there's a way for them to do it. It's unfortunately there's just no way to do like a standalone plugin for older versions of Unreal. But anyway, once you have it downloaded and unzipped, you got an RTXGI folder in here. This just needs to go into your 427 plugins folder. So I've got a shortcut here to that. So 427 engine plugins, and if you scroll down through, you'll find a runtime folder, and then there's an NVIDIA folder, and then you just put it in here. It's the same, like I said, it's the same process as the DLSS plugin, and you just drop the RTXGI folder into there. In my case, I think, we also include the level sample that I'm showing you here. We include that with the download, as well as some documentation. I just, for my own convenience, I take all this stuff and put it in the RTXGI folder, and so it's just right there if I ever want access to it. But that's got additional written documentation and the EULA if you want to read through it in more detail. But the sample in there is really useful because it's got a couple of test maps. This one's very simple, but if you once you get the plugin installed in Unreal, and then you go to your plugins preferences here, you can search for NVIDIA or you can search for RTXGI, and find the RTXGI plugin, enable it, restart, and then you're good to go. And then, like, if you load up the sample project is great for just loading it up and making sure that, oh yeah, I can see RTXGI is working. That was interesting. I must have said something. Yeah, that's why. Right. So yeah, and you can see there's a couple interesting details about this too, just right off the bat. You might notice RTXGI generates light from emissive surfaces. There's no lights in this scene except a dynamic light or a sunlight that's doing a slow rotate. So here you can see this blue surface is generating some light from that. There's a red surface back here that's doing the same thing. Just providing some soft indirect illumination. There's a lot of technical details about this too, and you get this for free. This is absolutely for free. Like, it doesn't cost any additional performance to have emissive surfaces casting light in your scene, which is fantastic. Just note that RTXGI doesn't have infinite resolution, right? It's not sampling your scene per pixel. Since the textures projected into the world are they're sort of lower resolution, and we do that for performance and overall quality reasons. That means that unless the emissive surface is got enough surface area to it, RTX-GI may not pick it up. So just be aware of that. If you have like really, really small, like lamp light, or maybe like tiny little light bulbs or something like that, RTX-GI may not be able to see those details. But if it's a large or broad enough surface like this, it can very easily see that. There's another, let me load it up. There's another, a second example map we have here, much the same way, except just a little bit of a sort of a larger space and a little more of a stress test of the system. Because like if I select the GI volume in here, we have a feature, visualize probes. I can click that and see all the probes in this volume. This is, as noted in the level, this is a maximum resolution volume, right? There's a limit to the number of probes you can have per volume, and that limit is described here. Basically, the probe counts, the X, Y, and Z value can't exceed a total of 16,384. That's because each GI volume is generating what we call an irradiance texture. Basically, sort of a cached real-time texture of the GI result that's being projected into the world. And since no texture can be larger than 16K in resolution, that gives you a maximum number of probes per volume. But you can see, lots and lots of probes in this one, tons of probes. And there's a couple of interesting. Go ahead.
Yeah, sorry. I just want to mention something that is worth, since you're talking about a maximum number of probes. That doesn't mean like if you need more probes or more accuracy, you can still add another volume, and the other volume can have its own limit of probes. So this number of probes doesn't mean this is the total number you can have in a certain level or a certain scene. You can extend that by adding more volumes.
Yes. Yeah, and we'll have examples that get into that too, right? These example scenes are kind of simple in the sense that they've each got one volume each, and for many scenes that might be fine. That's all you need, because a sparse probe placement in a volume can often be the right amount. Like you may not see much benefit getting, infinitely closer and closer with the probe counts. It's not, there's not going to be any real tangible benefit to that in terms of what global illumination can produce. But still, you want to try to fine tune those numbers, and multiple overlapping volumes totally works. Well, I just want to point out a couple of interesting details here. Something that you might notice: there's a number of probes in here that are black with a red outline. Those are probes that have gone to sleep. The system does this automatically. It can detect, is this probe seeing any relevant geometry? Is there anything that any reason for it to exist? And if not, it just shuts it down. And it's, since the GI is fully dynamic, it's calculating this every frame. So if something, a dynamic object, a character or whatever, moves into this location, then the probe can instantly wake up and start creating GI for that spot. Oh, whoops, I accidentally moved it.
They're wondering how much control do you have over the probe? So are they placed, is it all just always placed automatically, or can you increase, the areas that may need it and reduce the number of them in, more sparse areas?
Well, it's so by default, their placement within the volume is fairly automatic. Actually, you just saw that feature work. So you'll notice some of these probe points have popped off the grid, and that's because it's doing a very it's doing a dynamic calculation to determine whether or not the probe is inside valid space or not, if it's in a useful place.
Gotcha.
And if it can move itself to some place that is useful, it'll do it. You know, it makes that determination in real time. So, you know, with these corner ones here is saying like, you know, I can't like reasonably move to someplace better, or the surrounding ones are already providing enough correct GI. I don't need to do anything. I just go to sleep. And so it makes a lot of really intelligent on the fly calculations to do that. Now, if this feature, you can always turn this off too. We have that's automatic probe relocation. And if I turn it off, they just like stick to the grid rigidly. But we leave it on because I think most people will find that it's a good feature and it works really well. I've certainly I haven't seen a case yet where it's a good idea to necessarily turn it off. Although, you know, like I said, we provide it in case it's useful to you. But yeah, I mean, you have control over like the number of probes within the volume, and volumes are rotatable too. They can be positioned and rotated anywhere, right? So I can take this whole thing and rotate it if I'm trying to align the volume to like a house up on a hill and it's very crooked. You know,
Right.
if you feel like that gives you slightly better GI, it may not be necessary at all. In a lot of cases, like exact probe positions don't really matter, and people will find that I think that it does a very good job with the sort of the default probe placements. But if you want to get into like fine tuning those positions, you can do that. You know, I think though changing the number of probes in a volume, then, you know, maybe some minor adjustments to volume placement, and maybe even potentially rotating it, just depends on the scene, might be like the best things to do as far as fine tuning it goes. But yeah, so yeah, probes can automatically go to sleep. They can dynamically relocate. And yeah, you can, you know, the results tend to speak for themselves. Just like some quick notes on performance. Let me full screen this. Maybe that makes it a little bit easier. So this is a ray trace scene, right? And you can, at any point, you can always see how much RTX GI is costing you by doing a stat GPU. There's other commands, but this is like probably one of your most direct ways, or a simple way to do it. So within stat GPU, you'll notice two values. There's RTX GI update, and then usually located a little bit further down, that you'll find an RTX GI apply lighting cost. The update cost is your dynamic scene cost. Basically, this is the amount of time that RTX GI is taking to ray trace global illumination. And in this case, right now, that's consuming about 0.9 milliseconds. The apply lighting cost is the time it takes to take that generated texture and apply it into the scene. And that can be very screen resolution dependent. So if I'm at a 1080p display versus a 4K display, that apply lighting cost can go up quite a bit. But there are fine tuning controls for each. And like I said, I encourage people to check out those instructional videos, and I think we'll go over it here too. But there are fine tuning controls for each of these costs. So like if your update cost is really high, then there are certain things you can do there to get that under control. And conversely for the apply lighting cost. So usually just a couple of simple tricks to keep your RTX GI costs running really low. The technology is designed to run at, it's the general target is like 2 to 3 milliseconds for a fully dynamic GI in most scenes most of the time. But you can even get that number much lower if you want. it's entirely possible to hit like a 1.5 milliseconds or 1 millisecond or less, depending on what your performance targets are.
That's great.
Yeah. Yeah, we aim for high performance.
They're
Yeah.
actually
So
wondering, on that note, like what's the, we have pretty minimal impact on memory, things considered and whatnot, right?
yes.
Does it do anything like volume culling of probes that aren't in the viewing frustum to help with memory?
Um, Hammam might be able to answer some of that better than me, actually, because I think he's been a little more involved with it. But at the moment, no. Although we look at those things, we do have prioritization. So, nearby volumes can have, or more important volumes can have higher priority than others. And I think that's where things are right at the moment. But going into the future, we're looking at further optimizations to the technology areas there that can be improved for sure.
Yeah, correct.
I don't know.
I think
Anything you want to add, Hammam?
No, not much. I think you mentioned most of the points, but just to add, since we are like we mentioned memory, I think the big impact from memory is those radiance texture that we generate in runtime. So depending on how much probes we have, I think this is going to affect. So in the case you are showing us now, I think you have the maximum texture size. So that might have some impact on memory. If you have a smaller scene or less probes in your volumes, that might help as well. So this even like there is some impact on memory, but I think it's very easy to optimize and control in case that's a bottleneck in the scene.
Yeah. Individually, each probe has an infinitesimally small memory cost. It's not nothing, but of course, it can add up if someone were to go totally berserk with dozens or hundreds of volumes with maximum probe counts. It would be possible to start to consume more and more GPU memory. But in general, like most use cases, the memory footprint is going to be pretty low, and I think we can get into some of those how-tos, like how to profile for that as we go through this. But at this point, actually, I think I'd probably want to throw it over to Hammam to have him go over scene, unless we have other questions on anything I've shown or talked about so far.
There are a couple about the volumes, so maybe you'll go over this, Hammam, but they were wondering if you could like customize the volumes themselves, and then in addition to that, are they can they be controlled at runtime? So can you create or destroy them or scale them even at runtime?
Yeah, that's a good question. So for answering the controls in runtime, we have a bunch of blueprints node that allows changing a lot of the properties and parameters on individual volumes in runtime. So definitely that's something I'll be covering shortly. But what I would like to show now in my screen, this is I'm planning to show a bit more practical example on how to apply RTX-GI to some kind of interior scene. This is something that you might have in any game, like if you have interior spaces. So very typical scene. Also, if you're doing some ArcViz projects, you might have a similar case. So I think it's a representative scene to see how we can apply or leverage RTX-GI to light our scene. The scene is all is built from Quixel assets, so nothing special here. That I'm not using any additional content preparation or additional work to make these things work with RTX-GI. And this is one of the, I think, the big features in terms of workflow. You just enable RTX-GI in the scene and it does its magic and make things work. So this is the starting.
Yeah, can I point out something real quick? Just
sure. Yeah, go ahead.
So I hate to interrupt, but just that. No. Correct me if I'm wrong. The Quixel assets you're using are very high poly, right? And
yeah, correct. Yeah. So let me switch
to. They're not especially optimized in any way. This is one of the it's really great about the technology is that it's completely agnostic to things like material complexity and triangle count. Like, so you can, those aspects of mesh rendering will, have their own costs on the GPU, but they won't, like, you can have, million poly meshes and it won't make RTX GI any more expensive.
So yeah, this is the starting scene. In terms of lighting, this is how it looks like. We have one directional light that is representing the sun, and it's casting shadows all over the scene, except of course where we have windows and openings in the ceiling. So without GI, we see it's a very dark. We have a lot of dark areas in the scene that doesn't look interesting at all. So what I'll try to show how we can apply RTX GI in addition to some other ray tracing effects to achieve this kind of results. So I think compared to the previous case where the starting point, there's a lot of big difference visually. Like we have all those nice, warm, diffused lighting that is coming, that is bouncing from all over the scene. We have a lot of nice details everywhere. So yeah, it's a big difference. I think I have a sequencer here that I can play very fast to show different highlighted areas, how it looks like. Oops, need to switch. So yeah, like you see, like all those before in the previous scene, we don't see any of those indirect lighting on the ceilings. Mainly, everything was dark, and that's an interesting case because with other global illumination techniques, yes, you can achieve very similar results, but however, you have to go probably to and do some content preparation. So if you're doing a baked global illumination, you have to add light map UVs, or if you are doing using other techniques, you might have to deal with light leaking or other things. So you need to add maybe additional objects to block lights in certain areas. With RTX GI, this is all like minimized. Like you just again use whatever content you have, and it will work. So let me go back to the starting point and see how we can enhance our indirect lighting using RTX GI. So of course, like I think Richard, you already covered how to enable the plugin and install it. So I won't go through this. Yeah. I already have it added to my scene. So just to for adding RTX GI, it's like a few simple clicks. We go to the volumes and in the placement actors and scroll down until we find the RTX GI DDGI volume. So we just need to drag and drop this in our scene and place it around our to fit the content, scale it, and we're ready to go. I already have one added to my level. So if I go scroll down here under lighting, I'm going to frame it so you see it. So as you notice, like it is covering the entire content I have. It doesn't really necessary to be very tightly fitting the content, but if you can, that's fine.
Yeah, this is an important point. If I could just add to that, because it's like, yeah, I mean, you can. It's always good to maybe as you get towards the end of cleaning up the scene, maybe you want to tighten the volumes just right, make them fit your geometry just right. But it's certainly not necessary, especially as you develop, and you can certainly ship that way. Like you don't have to be completely perfect with the volume placement, or make every single probe count to get good performance out of it.
Yeah. So with this volume in place, I'm just going to enable it, and you can suddenly see how all our indirect illumination is calculated and processed in less than a few milliseconds, and we got most of the nice indirect illumination that we're expecting in such scenes when we have the sunlight going and bouncing all around the scene. So it is as simple as this. Only like drag the volume, put it into the level, enable it, and of course there is now several options that we can tweak to control the performance and the visuals of the indirect lighting. I'll be going through some of those, but before we do this, let me switch to lighting only so we can appreciate or see the impact of indirect lighting or RTX GI a bit clearer. So this is with GI, and this is without. So yeah, I think it's the difference is quite significant.
Yeah, no kidding. It looks great.
Yeah.
Yeah, that's off a single light source too, right?
Yeah, exactly. We only have one sunlight that is going through those small windows and the ceiling, and RTXGI is taking care of calculating all this nice indirect lighting on the ceilings and on the walls. And by the way, this is interesting. I think it's also a challenging case for a lot of GI solutions or systems, because when you have the lighting coming through small windows and you don't have a lot of lights inside the space, that makes it a bit harder for the GI to be able to sample or find the lighting sources and give you clean, smooth results. So what happens most of the times, if you have such scenes, you have either to increase the number of rays you are sampling, or in some system like, for example, Lightmass uses a smart technique where it allows the user to explicitly specify those windows. So the tool or the system will try to focus more rays toward those areas to get to sample enough lights without having to crank the number of rays. So if we search here for in the content for light portal, so we have the Lightmass portal. Those are basically the way that Lightmass allows people or users to direct the lighting through those small windows. With RTXGI, we see we didn't have to add any or do any additional preparation, but again, like, we can leverage some of those techniques, like add portals or whatnot, to improve or add some details or improve the performance, as we will see later. One important, interesting parameters I would like to mention here is the lighting multiplier and the emissive multiplier. So as Richard showed us in the simple scenes that comes with the plugin, RTXGI doesn't also only calculate indirect lighting from light sources, but also from emissive materials. I already have an emissive sphere here, and you see as I move it around the scene, the GI is updating right away. And we can control the intensity of the indirect illumination that is coming from the emissive materials, as well the intensity from the light sources, using the two parameters here. We have a light multiplier and we have an emissive multiplier. So in my case, I have the light multiplier set to 15. Again, this is something that's more on the artistic side, so you might want to have it very toned down indirect lighting, or maybe a bit lower, depends on the artistic vision for the scene. But in my case, I would like to crank it a bit so we can see the difference a bit clearer. Other thing that Richard mentioned is the probes, the number of probes. So for such scene, you might notice I don't have a lot of probes, like they have enough distance between them. But again, this is what this will give us is a bit more smooth, low frequency indirect lighting. If you are willing to have a bit more detailed and GI, you might want to try increasing those the number of probes in different directions. However, keep in mind that have some slight impact on the performance. Same thing with the rays per probe. So this is the number that we control how many rays we are emitting from each probe. So for this scene, as it is, I think 720 is giving me a very nice, stable results. But again, I can try if I want to optimize the performance to get it as low as maybe 432. But we start, like you notice, we start seeing some flickering here and there. So probably that's not a good value if this is the only lighting setup we want to go with. So I'll keep it back to 720, and we will see now, as we add a bit more of the ray tracing effects, we can go back and revisit this value and optimize it a bit more.
It might be good to point out that I just mentioned, since you're touching on that, it might be good to point out the probe history weight value as another way to control that, because that is something that they could do. Is you can
yes, correct.
You can you could if you don't need your GI to update every frame or as frequently, you can slow it down and produce a more stable result without a performance cost.
Correct.
So
again, like, there is a lot of parameters that allows you to balance between the visuals and the performance. So really flexible. Oops, that's too low, I think.
They're asking if you have any tips on how to do like physically correct settings for some of the light multipliers.
Yeah, that's a good question. I think those multipliers, they don't have physical units like what we have with regular lights, where we can use lumens or you can use other physical units. Those are more like multiplier factors that, again, depends on the artistic vision you have in the scene. You can control them.
Right. Yeah, typically, if you set it to, you leave everything at default, you set it to a value of 1, and if you go into your RTX-GI project settings and you set it to 32-bit mode, I think Homam can show that. If you set it to 32-bit mode, let everything at 1, that would be the technically correct, physically accurate GI result based off of your surface values and your light intensity. So, that would be correct. And even something else to consider too is how your post-process settings are going to affect the visual result, right? So you'll want to, if you want to see it completely naked, you'd probably want to be in lighting mode like Homam is, and then make sure your things like eye adaptation and your post-process settings are turned off, so that they're not modifying what's being put to screen. And if you did all that, then you would see basically physically accurate GI. Once you've got that sorted out, you can. I'm sorry, Homam, I keep interrupting.
No.
But once you do all that, then at least it gives you like a mental model, or you can take a snapshot of it or something. Say like, this is how the GI should look, and then you can go back and adjust the numbers to basically match it.
Yeah, correct. So just to mention one additional thing about those, like as Richard mentioned, like you can set this to 32-bit to get a more accurate results. However, keep in mind this have some impact on memory, because instead of storing 10-bit textures, now we are dealing with 32-bit texture, which is obviously has a higher footprint.
Memory. Right, 3 times the memory cost, 3 times the performance cost.
Yeah, so what I recommend usually is to keep this to 10-bit, and we have a parameter here in the DJI volume, which is this parameter here called 10-bit irradiance scaler, which allows you to compensate some of the energy you lose when you switch from 32-bit to 10-bit. Again, like this won't really give you the accuracy, but at least it will probably allows you to gain back some of the energy we lose from between 32-bit and 10 bits.
Right. So yeah, you'd only want to switch to 32-bit mode if you want to see how it should look, how GI should look in a physically correct way. And then once you figure that out, then make sure to put it back to 10-bit mode, for like a shipping product.
Yep. So basically, this is, I think, most of the important things you need to do to have a proper indirect illumination using RTX-GI. Again, just to iterate, no content preparation, no light map UVs, nothing extra you need to do. Just drag the volume, tweak the probe volumes and the lighting multipliers to have a decent balance between quality and performance. However, if we want to push this a bit more to have some of the extra detail that we see in path tracers or offline global illumination solution, we can incorporate additional ray tracing effects. So I'll show a few recommendations. The first one is basically using ray tracing input occlusion, because what RTX-GI is good at is giving you the bulk diffused indirect illumination, which is by definition it's like a kind of low frequency lighting term. So if you want to gain back some of the smaller detail occlusions that you see when you have GI in path tracers, I recommend enabling ray tracing input occlusion if the performance allow for that. So here, like this is without ray traced AO. Once I enable it, you can see we get a bit more contrast to the shading that we get from RTX-GI. So this is going to be added on top, which allows you a big artistic control. So you can tweak this radius to have less or more ambient occlusion. Plus, also we have all the controls for the lighting multiplier and the DJI volume. Additional thing also that helps, and I think this is a very common actor that when people doing look dev for their scenes is using the skylight. So in here I have a skylight, but it's disabled. A lot of people like to use it to get to sample some of the lighting that is coming from the sky. So in our case, we have a blue sky, so it's nice to see some blue tint included into those scene. By default, when you enable this, you get some kind of flat shading from the skylight, which is, again, it's good because it's reflecting the sky color in our scene, but it doesn't have a lot of the details. What I recommend also, if the budget allows for that, is to enable ray tracing shadows on the skylight, because that will give you the sky, will integrate the sky color into the lighting of the scene, but at the same time it will make it get occluded where areas it should be. So here, for example, below those ceilings, we should not get any sky color because those are all occluded. And talking about skylight, another thing we have, I think this is a recent feature we added to RTX GI, is the ability to include the skylight into the indirect illumination. So let me go to an area here and visualize the probes. So you see here, like for the probes that are close to the windows, we are expecting to see some of the skylight shading that we have, the blue tints added, but now it is not, because we are specifying that we don't want to consider the skylighting in the indirect illumination calculations. So this feature allows us to consider the skylight as if it's rendered through the raster pipeline or the ray tracing. In our case, because we are using the ray tracing shadows on the skylight, it makes sense to go with this option. Unfortunately, because now I'm on a development build, like we have this small issue. When you enable this, you have to go to the skylight actor and force refresh it. But you see, once I refresh it, you see, like we have here in this area, a lot of the blue tint from the sky started to be added to the indirect illumination we are getting from RTX GI. If I go back to the DDGI volume and disable this, you see this is without the skylight and the indirect illumination, and this is with. So this is another thing that you might want to consider if you have a skylight in the scene. So we have two things. We have the ray tracing emit occlusion, we have the skylight with the ray trace shadows, and we have a skylight integration into the DDGI volume. Another, or I would say a last thing that usually I would like to leverage or add to such scenes when we have, again, small windows where the light is coming from, is again a similar technique to what Lightmass do by of adding light portals. I would like to add rectangular lights around the windows and make those cast soft ray trace shadows. So I already have in my scene a bunch of those lights that I already added to all the windows. And you can see now, once I enable those, you will start getting a lot of nice, interesting contact shadows that have some directionality, as if they are getting some overcast light from through those windows. So this is, and again, this is all works very well with RTX GI. So we have a complete, I would say, integrated system where we have GI, we have the RTX GI that is giving us all those nice soft low frequency and direct illumination, and we have emit occlusion that is adding a lot of the details. We have skylight that is adding some of the blue tint to the shading, and finally we have those light portals or rectangular lights that's adding the nice contact shadows. So that's, I think, concludes some of the tips for applying RTX GI in this case. Yeah, I think I would like to show one more thing, since we have one of the questions asking about controlling the volumes or some of the properties on those volumes in runtime. So I'll pull up the full blueprint very fast. Okay, so here I have, before going to the blueprints, I have a simple animation on the directional light or the sun, just to show you also the nature of that this GI is all dynamic. So when we animate the light in runtime, we can see how the diffuse lighting is all updating, and it looks correct, we expect from a dynamic GI solution.
Yeah, this scene of yours it's not using there's no sky sphere object, right? This is volumetric lighting in sky, correct?
Yep. It's using the new Skylight Atmosphere actor. Yeah. So this is, I think this is clearer now without the textures. This is the GI with the certain lighting position, and this is how, like, you see how the GI and the indirect illumination all updated properly. I'll go to view some areas here. Let's go back to the blueprint example. So it's very straightforward, to be honest. Like if you use blueprints in for anything else, you will find it's very straightforward to control a lot of the useful parameters through blueprints. So you just need to drag and drop the DJI volume you want to control and the blueprint. And once you want to share the nodes, you will find a specific category for DDGI, and it lists a lot of the nodes that are supported. So as an example, let's try controlling the light multiplier. This is something you might want to do in runtime. So if you are changing the lighting scenarios depending on some events, or you're moving from different areas, or I don't know if for any other use cases, you might want to control this. I'll type it to a keyboard event very fast and use a flip-flop to switch between two states. So let's say we will set it when we press the J key to 5, and when we press it again, let's try something very big like 50, just to see the difference. Make sure I connect this, compile, and now when I run this, so this is by hitting G, we see now we tuned down the lighting multiplier from, I think it was by default 10, and it's getting back lower to 5. And when I press the G key again, it goes to 50. So very straightforward. And you can extrapolate the same workflow to control other aspects of the volume as well. Like we have all those controls.
Yeah.
Before wrapping this up, I would like to mention a few things about performance. So I think, as mentioned, Richard mentioned, like the first thing you want to start looking into performance is through stat GPU, where you have those two things. But we have also additional stat commands that can give you a bit more information specifically about RTX-GI. And one of them is, I think it's stat RTX-GI performance. And what this will give you a bit more information. So if you want, you can see how many samples we are emitting for the selected volume that we have here. In case you have multiple volumes, you can go through different the stats for different volumes using another stat command. And you can see another information like how many probes for that specific volume. In my case, it is 1212 by 6. And the thing that that's interesting is how much frame time in milliseconds the scene with RTX-GI. So in my case, it is 16.7 or 16.8 millisecond, and without RTX-GI. So you can see like how much RTX-GI is costing you in total. Again, like there is many things that we can optimize. So I mentioned that we can go back and revisit the number of frames per probe because we added a lot of lighting to the scene, like through the light portals and the skylight. So I think we can lower this a bit more, and we can still get some clean, stable results. So it looks okay with 500. I think we can even go a bit lower with 400 or even 228. Yeah, so it looks with 228, we have still very clean, stable results, as you see here. And now the difference is less than 2 milliseconds. I think we have 13.7 without and 15 milliseconds with. So I think it's very good investments in terms of performance versus visual quality or impact that you get from RTX-GI.
Can you show people how to constrain that in the RTX-GI preferences with the probe ray budget value?
Oh, yes.
I think that
yes.
that would be valuable for people to see, because that's probably, like, out of all the controls, that's the sort of the single most powerful tool in the toolbox to make sure that you're never firing too many GI rays.
Yeah. So
yeah.
So this is, I think, what you're referring to. So this is a very nice way to limit the maximum number of rays you are firing in the scene. In my case, of course, I'm not even close to that number, but this is, I think, more useful when you have a larger scene and you have many volumes, maybe like multiple volumes, and you want to make sure, like, at a given point, you don't exceed this number. So this is something that's useful to control it in terms, especially when you are creating the performance budget for the scene.
Yeah, I think many scenes can probably start with a budget of maybe 500,000 rays per frame. I mean, that's a lot, right? That's a ton of GI rays being fired in any given frame. But you can typically start with a number like 500,000, then you can adjust up or down from there to see if you need a little bit more or less. Sometimes you can get away with less too. But that's probably generally a good starting point to determine, to, like I said, or you just make sure that GI is never getting too expensive. And some number like that, whatever it is several 100,000 GI rays per frame, will make sure that your update cost is never over a certain number, depending on what you put in. So basically you're capping yourself at like 1.5 milliseconds or 2 milliseconds or something like that. It really does help to guarantee performance. Yeah.
Correct. Yeah. And again, like, just to reiterate, it's always good to go back and revisit the rays per probe and the number of probes, because what happens for me in this case, after I added more effects or more lighting, I was able to lower this number to a really good amount. So that will help a lot also in terms of performance. Before it was 720, so I was firing around more than 500,000 rays per frame. But after I added the lighting and other ray tracing effects, I was able to lower this down to 288 per probe, which is also something that's impacted performance.
Right. Yeah. The rule of thumb applies, right? Anytime you can do less of something, it's and still maintain quality, it's always better, especially in a real time context. We want to be practical about trying to make sure people can maintain performance, not just on a PC, but because RTX-GI can theoretically run anywhere. It can run on a PlayStation 5, Xbox One. And the static mode allows for even broader compatibility. We had one developer who was doing static RTX-GI on a PlayStation 4, so it has a lot of platform compatibility. It's not just tied to NVIDIA RTX cards. It can theoretically work anywhere you do graphics.
Yeah. So I think I'm almost done with the scene. If there's any questions about it before we move on to the next topic, I'll be happy to take it.
Yeah, absolutely. So let's see, I got a few here. Where they're wondering where sort of the limitations are. So, like, can you see ray trace reflections and can you see them with ray trace reflections and refractions? Is there support for grooms and other transparency? Where are the
I can take that if you want,
Cool.
Hamam, unless you want to answer it.
I'll mention. Yeah. Anyways, if you want to take it, please go ahead. That's fine. I was
Okay.
because I
would just say
have this sphere here specifically for that question, so I was kind of prepared for it. But yeah, please go ahead.
Then go for it. Go for it.
Yeah. So I'll cover the reflections part of the question, which is basically yes. For cube maps, we do consider GI in the reflections. However, if you want to consider ray tracing reflections, this is something that is not yet in this version of the plugin, but I think we are working on it.
Yeah. And the other question was about translucency. Like, do we support it?
Or like, how does global illumination interact with those various elements, right?
Right.
Yeah. You want me to take this?
RTX. What you probably know more about it than I do. I would just say that RTX GI, will generally it'll apply its result to any diffuse surface. Currently, it doesn't support translucent, like ray trace translucency, but that's also something being worked on. I don't know what you want to add to that, Hamam.
I just want to add a small point about having translucent object in the scene, because that's also something that we might find in production scenes. So in this case, for example, I have windows or glass. I want to see reflections, but at the same time, when you do this, because RTX GI does ray tracing, so the rays get blocked by those objects. So just something to mention, you need to disable shadow cast ray tracing shadows on those objects to be able to set for the RTX GI to have rays going through the window and sampling the lights or the environment behind it.
Yeah, and these are, of course, these are details that we're aware of and we're working on. This is a constantly evolving code, right? We're looking to improve it well into the future. So it's still evolving,
Yeah, just to show like this example here, you see I have a glass object on the ceiling on the windows. And I already, for the materials that is applied to this, I disabled the ray trace shadow casting on it. If I, for just testing purposes, enable the ray trace shadows and apply it, you see now the GI rays won't be able to go through this glass and sample the skylight or the lights coming through it. So we get a lot of dark scene now. So this is something just to keep in mind when you have a glass or translucent object in the scene.
Oh, that's a good note.
Yep, good question.
I can talk about one of the other limitations of RTX GI. It has to do with the probe-based method. This is really important to note, especially if you're expecting high frequency detail. High frequency detail in global illumination is, say you have a very thin ray coming in through a window and it's striking just like a small part of the floor, like just a couple inches or something. And you would expect there to be a sampled bounce light up from that tiny point. Like maybe it's a very hot light, very thin, small hot light coming in, striking that surface, and then emanating light up. RTX GI will tend to miss those details because the GI probes are 6x6 resolution octahedral maps, so they don't have a lot of fidelity. And like we've been showing you, you tend to get pretty good results by making them fairly sparse. Now, sometimes those details will get picked up, but it may not always see them. And so it just depends on basically the surface area. If it's a large amount of surface area, of course, it'll see it. But anything really small like that, like basically high frequency detail, it won't see. So, but this is an intentional choice of the technology, because what we're trying to do is we're trying to keep it very fast and very high quality. Um, you know, anybody who's used the built-in ray trace GI that's in Unreal by default, it uses a screen sampling technique, right? That's not probe based, so it's fundamentally different technology than RTX GI, and it can pick up those high frequency details. But as people would know, if you're using it, you tend to either need to do a ton of samples in order, and bounces and so forth, in order to keep the quality high, but then your frame rate suffers greatly, or you you reduce the sample count, but you get a lot of sampling noise in the scene, and the quality just isn't very high. And so you're dealing with those kind of trade-offs. RTX GI avoids those issues by simply declaring that, we're trying to keep this very performant by sort of going more low resolution. But that's a decision with the technology to, like I said, to make sure it's performant for games in real time. Because and it does result in higher quality too. Is we might miss high fidelity details, but it doesn't mean it's not high quality. Broadly speaking, the GI application is very, very clean. It doesn't have a lot of there's no screen sampling issues or screen space issues or any of the sampling noise that you might have seen from ray tracing effects in the past. So it has several advantages, but this is one shortcoming of the technology. Now, I would point out, just an interesting note to this is that everything we do at NVIDIA is also like an SDK form, right? Like, we're talking specifically about the RTX GI plugin, but there's an SDK that anybody can download and incorporate themselves. The people who made Metro Exodus Remaster used RTX GI, the SDK, as a basis for global illumination, and then they did a single bounce sampled lighting on top of that for high fidelity details, and that worked for their project. It came at a higher performance cost, but that's by limiting it, that high fidelity bounce to a single bounce. And only in that sort of like limited context, they were able to sort of strike a balance between quality and performance. And it's just interesting because it is like one way the technology can be used. Anybody can take the SDK and work with it and sort of roll their own solution like that.
Cool. Yeah. Do you want to show the other use case about RTX GI, Richard?
Yeah. You can grab my screen now if you want. Cool. Okay. I'll let me full screen this. Oh, whoops. Okay. So let's see. I'll do a stat FPS. I saw someone in the chat ask, what hardware is this running on? This is running on a 2080 Ti, so people are aware. It's it's a fast card, obviously, a 2080 Ti, but it is a generation behind. I'm doing that specifically so that people can see that this tech will run on the previous gen. It's not just a 30 series RTX card that it'll run on, and you can get good performance out of like a 2060 or 2070. It scales very, very well. But yeah, this scene here is meant to be. Some people might recognize this content. This is from some demo that NVIDIA showed a little while ago. Some of this content is from that, but it's just shows like a large ray tracing scene, RTX GI being used. In fact, I've got a toggle here, so I can turn RTX GI off, and you can see what the what the RTX-GI contribution is. So I'll turn it back on. Yeah, so in this scene here, it's meant to be very much a stress test of ray tracing in our technology. This right here, in fact, is this is all, so everybody's aware, this is also in our NVRTX branch. This is 427 NVRTX, where it has a number of our specific ray tracing optimizations for like shadow performance, reflection performance, massive amounts of foliage, as you can see. There's several 100,000 foliage actors. And this scene too is something that, you know, like a lot of the scenes we do, we want to try to get it out as as an example for people to work with and understand, and you know, so we, you know, further document it and so on, so they can see different ways to try to construct their scene or optimize their content for it. But you know, I think you know, you get the idea. There's a lot happening here, not just RTX-GI, but you know, volumetrics and you know, foliage, obviously, and there's ray traced everything that's going on: translucency, reflection, shadows, etc. And it is a fully dynamic scene too. That's part of the point of it. So like if I pull up in the air here, get a little more distance, you know, I can do a time of day change. You know, you can see what that looks like in real time. So the GI is changing.
Well, looks great. Yeah, they were asking in chat actually about how it performed with foliage, and then you pulled this up, so it's perfect.
Yeah. Well, I can get down here in the foliage a little bit and show what that looks like. I know it's not the explicit subject of this talk, but
Sure.
it's important too, though, because like, you know, I mean, RTX-GI, it'll work with all your raster effects. It'll work with ray tracing effects and raster effects. So you're not, just because you're using RTX-GI doesn't mean that you have to do ray traced reflections too, or ray traced shadows. This is the advantage to ray tracing. It's very much a grab bag of features, right? You pick the ones you want that make sense for your project. And, you know, most games probably don't want to use every single effect that ray tracing has to offer simultaneously. You know, you might want to be more selective. You know, translucency, for example, may not make sense for your project, or it may not make sense to have ray traced foliage in your scene. But here, you know, you can see RTX-GI working in the scene with ray traced foliage, and we've got, you know, animated material effects and you know, all the usual, you know, shadow casting and so forth, and you know, everything is working together as expected. I might have a tendency to move through the scene too fast too, so let me know if I should slow down or we need to look at something in particular.
And can folks
but
actually download this scene?
Not yet, but it's we're planning on adding it to our showcase.
Okay.
If you on the main page, our main landing page for NVRTX, right at the top, we have what's called the RTX Showcase, and it has the attic example scene where, you know, I don't know if we can pull that page up, but it just has an example there of like an indoor scene with basically every ray tracing effect that you can do. You know, like I said, all of them, including some of the ones we're going to be talking about a little bit later. But it's yeah, so it's like an everything example, and you know, it shows what you can do, but it doesn't have a large outdoor environment with foliage and so on. That's because, like, in the past year, basically we've been building all that stuff up and really improving it, and it's all that rendering technology is now at a fairly mature point where it's a good time for us to put out a further example of how that works and how to optimize for it and make the most of it basically. I think people will see the performance is very good. But in this case, I just want to show how the scene is constructed. I'll zoom way out here. Right. So you can see that it's a large space, but it's not an infinitely huge space, right? It's a decent sized map. This cube box here, this volume, basically represents the play space, and then everything outside of that is skybox with more foliage on it. And there's multiple GI volumes at play. So you can see in the sidebar here, there's 5 placed volumes in the world. And I'll show what some of that's like. Here's like a GI volume for the skybox, and that's huge, right? It covers everything. But it's not very dense at all in terms of placed probes. You can set your debug probe radius size. I'm going to set it really large because the probes are really spacious. Right? And then I'm going to visualize the probes on the skybox, so you can see. So here's a very large volume covering a lot of space, and really this is just to provide a bit of GI off in the distance. So this is one of the cool things about the technology, is that GI can be visible at any range. If you want it like way off in the distance, miles away, you can do that. If I turn off the GI, you see the mountain it gets a little darker. I lose some of that sky color. So it gives me that, and I'll turn off the visualization. And back to this, I'm going to set the debug probe radius to be smaller. We take a look at, so like there's a play space volume which covers, where you'd want like a higher fidelity GI. I'll visualize those probes, right? Hopefully that's fairly visible in the stream. You can see, again, the system is doing what it's supposed to do. It puts a number of them to sleep, like this probe is just hanging up in the air and not currently touching anything. These ones over here are near the ship, so they're active and they're generating GI because they're touching nearby geometry. So yeah, even with high probe count volumes, like unless your play space is packed to the gills with geometry in every direction, it's unlikely that you're going to have all your probes active, right? A certain number of them at any given point are going to be automatically put to sleep. It'll even do that for ones under the terrain, right? So you can just stick them through the terrain. That's okay. They'll go under, and then the system will go, oh yeah, it's not in valid play space. It's behind geometry or inside geometry, and shut them down.
Yeah. One point I think worth mentioning, Richard, about probes that are gone to sleep. Yeah, that's definitely something that is going to help optimize the performance for them. But I'm not sure if they will still be counted in the memory because they need to have their space reserved in the textures.
They do. Yeah. They do count towards memory,
so,
just not towards performance. Right.
Exactly. So I would like to recommend try to keep the number of probes optimized. So if you you have a full row of probes that are below the landscape, that even if they went to sleep, they are still having some additional costs on the memory. So it makes sense to bring them up a bit or remove them if they're not needed at all.
Yeah, that's a good point. It might be worth pointing out that one of the things, I'll just mention it, we've talked about it, we're not actually doing it, but we've discussed it, is the idea of doing more optimized ways of placing probes into the scene, right, to further optimize probe counts in memory, just to help mitigate some of these issues. Because you might have this type of situation where your terrain is really steep, and you're having a lot of wasted probes essentially. And you're like, oh, this doesn't look very good in terms of memory. So we've discussed things like having a terrain actor where the probe allocation follows the shape of the terrain, and more closely rather than in a fixed grid system. None of that's done yet. That's not currently being done, but we're discussing those sorts of ideas as ways to make improvements to the system. But I will show that you might notice that these the probe placements here are on the X and Y. They're a certain distance apart, but on the Z, they're more spacious, like 2 or 3 times the distance. And that's because I made it intentionally, since most of these probes are up in the air and not very useful, I just sort of made them more sparse in that direction. I have a separate volume for the terrain. Hold on. Excuse me. I'm going to get some water.
Sure. Yeah, you mentioned you have multiple volumes in here, and they're wondering what happens if they're overlapping, or how do they interact, or do they?
So the system is it's intelligent about that too. It'll take the probe volume that's the most dense one and use that. So it automatically looks at density values and just uses the densest one. But you can always override that. We have a lighting priority value in the GI volume, and so if you want to manually have a volume, with a higher priority, you can set that value directly so that it always takes priority. Let's see. So yeah, I have a slightly the same size in the X and Y, like it covers the total play space, but I have it a little more dense here down at ground level, where I want like a little bit, just a slightly more fidelity in the GI. And over here, I have got one specific area with a cave where I want just a little more fidelity than the general map. And so in this case, there's a certain amount of density just for this spot here. And when it comes to like the edge point, you can set blending distances. So there's a right here in the GI volume, you can set the blending distance. So this is an Unreal unit, so it'll blend by that amount to the next adjacent volume or the one it overlaps with. And of course, you can overlap multiple volumes. I forget, Hamam, what is the current number of maximum volumes in a scene? Do you remember?
It
escapes me because I know
honestly
we increased the limit. It used to be lower. It used to be, I can't remember. At one point it was like 6, and then we doubled it, so you can keep adding more volumes, right?
Yeah, I think it's like there is no hard limit for the number of volumes. It's just something that we hard coded, but yeah, we can definitely increase that number.
Right. This is something that we're constantly seeking feedback on too, right? Like ways to improve this whole system, number of volumes, like what are the needs of the project, or what do people need to do? You can see, like, I'll just turn those probe points back on. This is roughly the same probe scale as what Hamam had in his test scene, and you can see, you get pretty good GI out of this. Like about what you'd expect. If I, looking at this, there's some light bounce happening around here at the river's mouth, but it gets darker as it goes into the jungle, like you'd expect. In fact, a lot of the lighting in here is really the result of just skylight. A little bit of GI. Actually, here's some GI. You can see it happening right there, where the light is coming into the scene and then bouncing off the the broadleaf, and creating a nice ambience right there. But yeah, multiple volumes. There's one around the ship. Or visualize those probes. So yeah, a lot more dense here.
Yeah.
But that also makes it. Oh, whoops! I'm nudging stuff. See, like I said, you can go into your project settings and RTXGI, and set this debug probe radius to something more sane. So there, I can a little bit easier to visualize. I don't remember if I mentioned it already, but the GI result at any given location is visible right on the probe. That's the default behavior. So if you're wondering what the GI is seeing, we display that, like basically the probe texture is right there.
It's a reflection of that, or yeah.
Yeah, exactly. For whatever GI is it's picking up. Yeah. So yeah, and in this case too, there's one more GI volume, and this one centered on the player. So let me hide the ship one, and we'll pick the player, and he's got a GI volume attached to him. Now, I mean, of course, a person setting this up, right? I just did the simple thing of taking a GI volume and attaching it directly to the character instance. I think a proper setup would be to do it through the blueprint, or through code or something like that. But as a simple solution, this works. We have a feature in RTXGI called Infinite Scrolling Volumes, ISVs, and that's controlled with this flag right here, scroll probes infinitely. So let me visualize these probes. This is just basically it's a GI volume that's centered on the player and moves with him. So if with that flag off, you can see the behavior that the probes take. If I just drag the volume through the world, it does what you'd expect. They slide around, and then it recalculates when it gets to its new location. But with that flag on, instead of the probes within the volume sliding around physically through the world, they stay fixed in their position. And as the volume moves through the world, the probes at one end warp to the other end. This way, you get a very stable GI result. That's also moving with the player and sort of gives you, like higher fidelity GI infinitely, over any size play space. So you can see if I leave the probe debug on, we can see how that looks in real time. It's like picking up the color values, and then these ones are going to sleep. And you see it's just moving with me. And this is you can have right now any combination of setup, right? Like there's no hard rule on this. It's really just how much detail do you want, what's your budget, sort of what's important to you in your project. But you can, by using this, and then maybe you could have like a large static GI volume over your whole level, and then you could have like a much smaller ISV volume, like on a player, and maybe he's even got multiple. Like you could have a smaller one on him, and then a larger one for more distant dynamic GI. And just with like 2 or 3 volumes, you can cover any size play space. My point is that you don't have to do what I've done here, which is create a lot of specific volumes for specific areas and go that route. That's only if it matters to you, if you want to make sure you see high fidelity GI in the distance. But this works too. As I move into this area, you'll see that like the GI probes, they get a little bit of green on them as they're absorbing the foliage, picking it up and so on.
Oh, that's really nice.
Yeah. Yeah, this is in some ways this is your simplest implementation of RTX-GI. You could just have you wouldn't need to place down any pre-placed volumes in any environment, and that might work for a game that's fully dynamic or procedurally generated. You might just want to have an ISV on the player and call it a day, and that's your GI. Um, and so you're only worried about optimizing this dynamic volume that travels with the player and making sure that it's, it's you've got good project settings and so forth. Um, and that's a very simple solution. But like I said, you can have multiple overlapping ISVs if you want, or any combination of ISV and placed volumes in the world. Um, it's important to point out that the ISV feature is still a beta. I know everything here looks like it's working great, but it's not. This is not a final feature. It's still undergoing something of a code refactor. But I think there's going to be an update where we'll say that it's no longer a beta feature. It functions right now though in the plugin, so anybody can start using it and get to working with it. But yeah, just know that at some point it's going to improve. Yeah, we're looking at a number of performance optimizations, quality improvements. There are a few visual issues to fix. Um, so that's just people should be aware it's not 100% final yet, but getting close. It's a little hypnotic,
awesome.
right? To see the
Yeah.
probes moving around like that. So it's kind of trippy, a little weird.
Mm-hmm.
Well, awesome.
Yeah.
Is there more you
I
wanted to go over in this scene, or?
well, only if we want to move on to the next topic. I'm not sure if we have any other questions up to this point. I'd certainly like to answer them, but even if they're not directly about RTX-GI. But
Okay. Um,
yeah.
Sure. So on everybody's mind as you're talking about updates, they're curious about its UE5 integration, and we've also had a number of questions about what does NVIDIA's RTX GI mean for like the in-engine global illumination? Do they work together, or do you totally turn one off? So can you kind of speak to a couple of those?
Sure. Well, I'll just say we don't have an Unreal 5 version of the plugin yet. From a coding standpoint, I think it's well understood that 427 and Unreal 5 they have a lot of similarities, at the back end, but they're also different beasts, right? They're just different different code bases in many ways. I mean, an RTX-GI plugin for Unreal 5 is something that we're working on, and we expect it'll happen. I just don't have a release date or any sort of specifics that we can talk about yet. But Unreal 5 implementation of this technology is something very much on our minds, and we're working towards it.
Cool.
What was the other question you had?
So they were wondering if you all have done any sampling to know how this may or may not interact with Lumen, for one. But obviously, totally understand that's all under development. So if not, all good.
Oh yeah, I'd say we don't fully have answers there yet. I mean, because we don't have RTX-GI yet running in Unreal 5, so we don't have it to directly compare with Lumen, or exactly how will they interact and those sorts of things. I think it's worth pointing out though that because I think there's been some misunderstandings about this, that ray tracing in Unreal 5 I think is going to be very strongly supported going forward, where for our development effort, we're we're coordinating with Epic all the time about, with you guys about, exactly what implementation, these rendering features will take. And so we're just in the process of hammering out those details, but we're putting a lot of effort into continuing and developing all these technologies going forward, and no intention of slowing down or stopping. Unreal 5 does some interesting things, and I think Homam can speak about this too, because he's done probably a little more research on some of the Unreal 5 aspects than I have. But it's ray tracing in some ways is even more supported in Unreal 5 than it is Unreal 4, because Unreal 5 has the software shadow implementation, which gives end users even like sort of more backwards compatibility. If someone doesn't have ray tracing hardware, there's like a software shadow fallback that they have access to. I think a lot of the questions, though, probably revolve around exactly how is all this stuff going to integrate together? How do you select it? What choices make sense? We don't have answers for all that stuff yet, but like I said, we're working on it.
Cool. Homam, did you have
sorry, anything you want to have?
Yeah, I think you covered most of it. I just want to mention that based on my initial research in Lumen and Unreal 5, I think ray tracing, as you mentioned, it's well supported. However, it's a bit different from what people are used to have it in 427, because in 427 you have to explicitly enable those different ray tracing features from your post process or other places. However, with Lumen and all those new systems, they are more integrated. So if you have the hardware, I think you can benefit from having ray tracing with Lumen to have a better fidelity in terms of reflections and maybe GI.
Yeah, I mean, I don't know. I think it's probably there would be strengths and weaknesses to any choice a person makes, but there's going to be a lot of rendering choices going forward. It's kind of an impressive amount between like all the different ways that you're going to be able to do reflections and GI and dynamic versus static and so on. There's the amount and number of ways that you can do graphics is going to keep going up and up and up, and that does kind of segue into the next part I'd like to talk about, which is RTX DI. If unless there are other questions, I'd like to.
Let's do it, and then
that.
we can answer any additional questions at the end. So go for it.
Okay. So just to hold on just a moment, just to start that. How about Homam? I'll show them this, and then you can show your scenes. Does that sound good?
Yeah, sure. I think my scene is going to tell a lot of details.
Cool. Yeah. So I didn't mention it before. This is not just an RTX GI scene. This is also RTX DI. Like I said, this is on the NVRTX branch. This is our optimized ray tracing branch of Unreal Engine 427. Well, first off, what is RTX DI? It's short for ray traced direct illumination. And the idea behind DI is that it takes all of your shadow casting lights in the scene and renders them in a single pass using an entirely new denoising algorithm. So that denoiser and the RTX DI technology exists in the NVRTX branch today, but going forward, we want to make it more and more available. So you can get to work with it today and use it in the branch if you wanted to. But what does it give you? RTX DI is a technology that allows you to, like I said, to take all your shadow casting lights and render them in a single pass. So that basically means performance. Without it, you're constrained by the number of shadow casting lights you can have in your scene, which is basically the same limits we've been dealing with for 2 or 3 decades at this point. Typically you might only be able to afford a handful of shadow casting lights, maybe 3 or 4, maybe 10. It just kind of depends on your content, or what sort of performance target you're going after. RTX DI theoretically can handle hundreds of shadow casting lights, thousands of shadow casting lights. So there's an example of that here with the interior of the ship. I mean, this whole scene is lit by a sunlight, right? It's got a direct light for the whole thing. But inside the ship, there are about 60 point lights all placed around. They're all shadow casters. They're all over the place. With RTX DI enabled, not only does it get rid of a lot of the sort of the noise sampling issues, because it samples them in a different way. So in some cases you get better shadows or improved shadows, but it also gives you better performance. It reduces, you're not paying for a per lighting cost anymore, a per denoising lighting cost. So yeah, this scene here, running on a 2080 Ti with 60. Well, actually, there's the lights off of his back they're all RTX DI shadow casting lights. So there's lights in the tunnel and placed all around in the environment, and there's and they're in some cases very large radiuses too. Like there's one below the surface there. I mean, there's light being picked up down here from RTX GI, and it's bouncing some soft bounce light up here, but then there's also light being projected from a large point light source that's helping to fill up the space. This is all technology that helps to get us sort of a step closer to real-time path tracing. I'm not saying that's what it is, but it gets us, if you can do just an unending amount of lights in your scene, and plus global illumination and other details, you're kind of start to talk about scenarios with unlimited lighting or near unlimited lighting, not constrained by a lot of the constraints we've had before. I would point out too, just like RTX GI infinite scrolling volumes, this RTX DI right now in NVRTX is a beta feature. So yeah, like I said, you can use it, you can develop with it, and we definitely encourage people to try it out and give us feedback. I mean, we want to hear what everybody has to say, but it's currently in beta, so there's still some details to work out. And as capable as it is right now, we expect it's going to just keep improving. We're looking at, maybe I should just, you know what? I should I should stop talking too much about this, and I should let Homam show us some of the examples since he's got, because they're really good.
Yeah. So if I can switch to my screen, I'm not sure. Yeah, we see this is one of the test projects. I built this, but I didn't have the chance to finalize it. So apologize for missing materials and textures. Anyways, the goal that I would like to show here is the scalability, or the number of lights that we can afford with RTX DI. So here I have a couple of amusement park rides, and each one of them has hundreds of lights. You can see from the radiuses that we got showing. And not only that, each one of those lights is basically a point light that is casting ray trace shadows in the scene.
Yeah, look at the number of lights he's got going on here. That's incredible.
Exactly. Yeah, so we have a ray tracing shadows happening from each one of those lights, and additionally, I added small spheres, glowing sphere, just to represent the lights. So a lot of rendering happening in terms of lighting. again, we are talking here not about tens or hundreds of lights. I think we are around 2,000 lights. Let me confirm that. We have stat light rendering. So
yeah,
as I mentioned, we're very close to 2,000 lights. Sorry, yeah, go ahead, Richard.
I would point out, and this is all based on SDK technology that was, I think, provided at the link, the developer on NVIDIA.com RTXDI link. That SDK, there are test scenarios that have hundreds of thousands of shadow casting lights. I think they've even done millions and gotten, consistently really good performance. No difference with adding, another 2,100 lights to the scene. Doesn't matter. That's not, we're not there yet with Unreal Engine. Like we're some number less, but still, much higher numbers than of lights than we've been dealing with to date.
Yeah, so that's the point I was going to mention. So even I have 2,000 lights. Yeah, I still have decent performance. However, unfortunately, the performance, if you notice in the stat unit, it's kind of bottlenecked by the CPU threads. So I think if we are able to optimize some of the CPU overhead, and that is happening because of processing all those number of lights, we can get even higher number in terms of performance on the GPU. And just to show the impact of the CPU, let me hide the light rendering stats. I have some kind of procedural animations on the rides with along with the lights. So if I enable this, see how the frame rate drops drastically. So I was around in the 80, 75, 80 frames per second. Once I enable the animation, it drops to 7 or 8, and this is because we have to process all those individual lights on the CPU in terms of animating, updating the materials, colors, and so on. And this is something maybe I would like to, if we have time, I'm not sure how much left we have, but I would like to do a fast overview on how we can optimize some of those overheads on the CPU to help unleash the RTX TI power and not having it bit limited by the CPU. So just to go through,
I think it'd be cool if you could get into it. Yeah, if Amanda thinks we've got time.
Yeah, go for it.
Yeah, cool.
Okay.
So yeah, if you took a look at one of those rides, how they are built, I'll open. It's basically a blueprint, because obviously I don't want to manually place those lights individually in the scene along with the spheres. So I have a blueprint that takes care of adding those lights along a predefined spline. So I just have to draw the spline and then just specify how many lights I want, and it's going to add them. However, if we look at the code for adding them, here we see only like just some high-level functions, because all those rides are inheriting a base class that implement the basic functionalities for adding lights and animating them procedurally. So I'm going to double click on one of those functions to jump and see how it is built. In this first section, we are just calculating where the light's position should be. And here we are adding those individual point lights I mentioned. And you can see we have like different intensities, and they are casting shadows, ray tracing shadows to be specific. And then we're attaching them to some kind of parent to be animated with it. Now for the light spheres, the emissive light spheres, those are added as static mesh components, and they have a dynamic material that allows us to animate their colors during time. So this is the dynamic material. It's very simple. We just have a color parameter, and in the animate light function, we are updating the color of that parameter, and we're updating the color of the lights depending on some color curves that we provide. So those color curves basically specify how what lights will be colored through time. So it will start with the black color, then it will gradually shift to blue and orange. Same thing for other lights. So just looking at the setup here, how we are doing this, you can, I think, tell that we are wasting a lot of time processing all those individual light spheres and lights to update their colors, to update their intensity, and so on. So what I did, I created another scene. It's going to be exactly the same, but using a different approach. It's this one. So we have the same content, the same amount number of lights in the scene. However, if we go and check the performance, you see now we have everything animated, but instead of dropping to 8 frames per second, we are still in the 40 frames per second. So by doing simple optimization that I'll go shortly and explain it, we gain more than 30 frames per second just by doing this optimization. So what we did here is basically, again, let's take a look at the blueprint, this one for example, and let's check the add lights function. So before we were adding individual static meshes to represent the light spheres. Now in this version, what I'm doing is I'm using the instance static meshes and adding those spheres as instances. Obviously, this will helps a lot of the draw thread, because instead of having to initialize a lot of draw call, this is going to be all batched together. So that's one thing. However, by doing this, we have kind of challenge, because now how we can animate the individual lights, individual light colors of those instances, like we did in the previous version. By default, when we assign a material to an instance static mesh, all the instances will use the same material, and if we change the parameter on that, this parameter will be changed also for all the instances. One interesting feature I recently discovered in Unreal, I'm really proud about it, it's that you can, for each instance, you can assign a custom data per instance. So that's a really interesting thing that allows you to do a lot of great optimizations, like what I'm going to show here. So for each instance, I'm basically assigning the ID of that instance, and in the animation section or the blueprint, instead of going and updating the dynamic material parameter, I am doing this all in the shader. So if I go back to the shader that we have, it's this one here. You see, this is like the animation logic now is moved from the blueprint to the shader, so it is completely evaluated on the GPU. In this section, I'm basically fetching the custom data that I assigned to the instances. I'm using this information to offset the animation based on time, and then interpolating the result from the vertex shader to the pixel shader. And then I need to, that's another also interesting feature in Unreal, we need to now fetch the color information from the color curve asset that we used before. So I showed you are using those color curves to animate the lights. However, those assets, we can't directly access them or sample from them in our material. But also there's a very useful asset in Unreal, which is a color atlas. I think it's under miscellaneous here. Yeah, this one, curve atlas, sorry. So what this asset allows you, it's basically, it takes any of those color curves and creates some kind of lookup table for you that you can access in the material. This is a really nice feature that allows you to do this kind of workflows. And the cool thing about it, it makes this lookup table interactively. So if I go and change the color here, we can see now it's going to update. Oops. Yeah, you see it updated directly in the lookup table. So that's really neat feature. And that's how I'm basically accessing those color curves in the shader and keep them in sync with the light colors. So just by doing this, again, if we go and look at the performance now with the animation, we have around 40 frames per second versus if I go back and load the previous scene. Play the animation on that scene. We have 8 frames per second, so from 40 to 8. That's big performance gains here. And again, this is all by just optimizing how the CPU is processing our scene. Again, like RTX DI is doing really great job in rendering those 2000 lights and even more on the GPU. However, because we have those as individual actors and the way we are animating them, that makes also a big impact. Now, this brings me to another interesting feature, because when we deal with this number of lights, or with the way we animate those lights, for some use cases, I think it makes sense to leverage Niagara. I think most of the people knows that with Niagara we have, let me load an effect here. Yeah, we have a light renderer that allows you to attach lights to your particles and animate them in a more efficient way, instead of having to animate each individual light or process them in the blueprint. So that's a very interesting way or approach to handle this number of lights. However, by default, we know that Niagara Lights doesn't cast shadows, and that makes sense without an RTX TI, because basically the amount of overhead of performance we will end with is not really something practically we can use in the scenes. So with RTX TI, this is one of the interesting new features we got, is now we have support of Niagara, ray trace shadows on Niagara Lights. So this is a simple scene where I have a particle system with light attached to each particle. Let me go switch here. Try to squeeze the space. And you see by default, this is what we get. We have nice lighting coming from the particles and lighting the scene. However, we don't have any of none of them cast any shadows, or we don't get this nice depth to the scene that we get when we have shadows. So with RTX TI, we have a new option now with the light renderer, which is cast sampled light shadows. So when you enable this, you see now each one of those individual Niagara lights is now a ray trace shadow caster, which is really impressive if you compare how the scene looks like after we have all those nice soft shadows that are animated based on the particle lights, versus without any of the shadows. So really excited feature. So in case now you want to do a bonfire or something that is that needs to cast shadow, you don't have to fake it and add another point light and try to synchronize the light animation with the particles. You just can literally have each one of those lights cast ray trace shadows and runs at real-time frame rates.
That's really lovely.
Yeah, this is really the point of technology like RTX TI, is we want people to have access to unlimited dynamic lighting, at least as much as we can, possibly muster. It dramatically help workflows. You can put down as many lights as you want. I think a lot of content people, whether you're like a lighting artist or a level designer or whatever, you might do a lot of work where you're optimizing, this direction you get 10 frames per second, this other direction you get 60 frames per second. And so you're trying to optimize the 10 frame per second direction. A lot of it comes down to things like, there's draw calls and triangle rates, but a lot of it too comes down to how much lighting complexity are you dealing with. And RTX TI has the capability to just eliminate those costs, right? Just put down as many lights as you feel you need to make your scene look good. And don't worry about, I've got too many lights over here versus there. It could make it so it's really more of an aesthetic choice rather than a performance choice.
And the fact that all your lights are ray trace shadow casting lights, that's also very impressive.
Yeah. It's huge.
Because without RTX TI, I'm quite sure my GPU will go out with TDR and hang my PC. So we will be getting a couple of seconds per frame instead of having 60 frames or 70 frames per second.
Yeah. I know we're right up against. We're right at like 2 hours, aren't we?
Yep.
Okay.
Yeah.
Okay. I know we're going long. There's just one more thing I want to show. It won't take long to do, if that's okay.
Sure. Yeah.
Okay. You can share my screen now. Okay. Yeah. So this is the Infiltrator demo. It's available on the marketplace. I think a lot of people are familiar with it. It's the same demo people have seen, but I have it enabled for RTX TI. But not yet. Right at the moment, we're seeing it with this is raster rendered. So I've done two things to it. I've stripped out the light maps. So it's all dynamically lit. And everything is shadow casting. And I think the scene has something like 1,800 shadow casting lights in it or something. It's in that ballpark. It's a lot. It's over 1,000 shadow casting lights. And so I'll just play that a little bit. So here we're not ray tracing it yet. This is raster rendered. And yeah. Yeah, I'll cut down. I don't know if my audio is coming through, but anyway, it's raster rendered, and you can see that with like everything being dynamically lit, it looks great. But you know, it's doing exactly like I was describing. Like the performance is variable depending on where you're looking. You know, in some directions you get 30, but then other directions it drops way down to like 15 frames per second. You know, this is where an artist, you'd have to bake the lighting, or you'd have to cut the number of lights, or do any number of things, right, to try to make it run the way you want to. So I'll enable. Actually, let me go back to the start. So yeah, here we're looking at it raster rendered. I'll enable RTX DI. Right, and there you go. And actually, now you can see that with that many lights, RTX DI is running faster than the raster version. And again, this is on 2080 Ti hardware. So this is a generation behind. You know, and this is without DLSS or any other image scaling technologies too, where it would get even more performant, right? So it's possible to get the frame rate up beyond this. This is just a very quick you know, sort of demonstration of what RTX DI is capable of doing. So if I, you know, same thing, but now I run it ray traced with RTX DI. Let's give it a second there. Yeah, you'll see that. So yeah, instead of 15 frames per second in the beginning, it's running at 30 some frames per second. And you'll notice now that just about in every direction, it doesn't matter where the camera is looking, because all the lights are being processed in a single pass simultaneously. You're getting about this, roughly about the same performance, you know, at all times. You don't have like a specific optimization that you have to do over in this area or versus that area. It really does help to even out the frame rate and make it much more consistent.
Yeah, and that's great for, you know, making
that's it.
very smooth.
I just wanted to show that. And anybody could do this themselves too. Like we have like I said, the NVRTX branch is up there. It's available for anybody to download. Anybody can download the Infiltrator demo off the marketplace and plug them together. You just, you know, it's enabling RTX DI is there's a if I search for NVIDIA. There's a real-time denoiser, NRD Relax. That's the new denoising system that allows you to take all the lights and render them in a single pass. So you just enable that plugin, and then turning on the feature is just with a CVAR. It's this ray tracing sampled lighting 0 or 1. And yeah, so like here I can. Yeah, so this is with ray tracing off, and then ray tracing on. Okay, that's it. I think we're good for questions or wrapping this up. I don't want to. I know we're over time.
Sure, that's okay. But yeah, there's a few more that we'd like to go ahead and cover for them. So just to clarify, we've had some folks that have come in a little later.
If someone's talking, I can't hear.
Oh. Uh-oh. Richard, I think your audio betrayed you. Can you all hear me, Hamam and Tina?
I hear you, yes.
Oh, okay. Well, I guess
okay.
It's a question for Hamam.
I got it.
Okay.
I can hear now. Sorry.
All good. No, I was going to say...
So there was a question? I'm sorry.
We'll get into it. Now I'm going to present your question. So we've had some latecomers come in, and they're asking, you know, so RTX GI is a plugin that you can download and install, but then RTX DI is through a specific branch, correct?
Yes, and
Yeah.
I mean, if we could give it as a plugin, we would. It's not possible at the moment because RTXDI is a technology, and the denoiser NRD that goes with it. The two of those together, it's a fairly large engine change. It's basically too big for a plugin, and I believe there are some engine side hooks that don't exist yet. So we're looking at direct engine integrations for that technology right now.
Cool. In regards to the scene, the beautiful carnival scene that you had, they were
Oh, yeah.
wondering, or with the eye in general, like, can you speak to how lighting calculation priority? And so, like, which systems calculate first? So there's the plugin for GI versus like Unreal lighting solutions. How do those interact?
Yeah, so just to give you a bit of context, like for that specific scene, I don't have RTX GI enabled on it.
Okay.
It's only direct lights. It's all built from point lights. As I mentioned, each one of those is a ray tracing casting shadows light. So that's a lot of ray tracing shadows happening in that scene. But again, because RTX GI works in a stochastic way where it goes and samples the lights without having to have a full list of all the lights and that need to go through each one of them one by one. It does process or render those lights on the GPU in a very efficient way without having to like affect the performance drastically. I think again, like for the amount of lights I have in my scene, if I disabled RTX DI, it's going to be a couple of seconds per frame instead of
Right.
60 frames or
Yeah.
70 frames per second. Yeah, it's a big difference.
Probably wouldn't even get 1 frame a second.
No, definitely not. I think I tried it one time before my engine crashes. It was like 3-4 seconds to render 1 frame. Yeah.
So many lights. Love it though.
Right.
They were actually curious if you could share the like attenuation radius of each of those lights in your scene.
Of course, I can get that. They're fairly large. I think they are set by default to their to the default attenuation. I didn't change
those
it.
look like 1,000
Which is
radius lights.
yeah,
or
it's
something.
1,000. Yeah, exactly. It's 1,000 units.
Yeah.
Again, but
impossible numbers of them, right? Like way too many really large radiuses. None of that matters in terms of performance for the system. I mean, there is a breaking point, right? Where if you just have so many, it's been a discovery for us to try to find out exactly where those breaking points are, and some of them come, in unexpected ways, and we're like
I think so far,
out with this.
So far regarding the Unreal integration of RTX DI, the main bottleneck will be the CPU. So that's why I was hoping to show some of the ways I went to optimize the performance for that. Again, one thing that we are planning to have is supporting RTX DI on emissive materials. I think once this feature is integrated into Unreal, that will be a big optimization opportunities, because you don't have to go and pay the overhead cost for each individual point light or light in your scene. You just add static mesh spheres or whatever mesh you want with emissive materials, and RTX DI will be able to handle this as a ray casting light.
Right. This is a huge deal potentially. It could potentially change how we light scenes completely, right? Because in theory, you could have nothing but mesh lighting. I would point out that this works in the SDK today. So if outside of the Unreal Engine, if you were just developing with the RTX DI SDK, you have mesh lighting in there as a feature. It's not implemented yet in the Unreal version, but it's like Humam said, it's something that we're looking forward to.
Awesome. They're also wondering what's VR support like for all of this. Does it work?
I think Richard, you did some tests with RTX GI on VR, right?
Yeah, RTX GI is at least partially supported in VR now. There may be circumstances where it doesn't work as ideally. I think the there are still some, in general, some steps with ray tracing and VR that sort of need to happen to make it really fully capable. Like, for example, a lot of VR development, you want to, you want to use the forward renderer. You probably want to be in DX11. Those things aren't compatible with ray tracing. Ray tracing requires DX12. It requires deferred rendering. And you can do those things with VR, but there's performance implications and sometimes quality implications. So it does get a little complicated. But I can say that RTX-GI does work, at least in many circumstances, for VR, but other ray tracing effects not fully. And yeah, this is just something that is going to need more development time.
Yeah, totally. Somebody was already checking out the RTX DI download page. They said it shows Visual Studio 2019, but does it also support the latest 2022 version?
I'm not sure about that, but yeah, we can
Yeah.
answer. Yeah.
Yeah. This is also like they need to check if Unreal Engine like support 2021, because if they are building it through NVRTX, like they need to be able to build Unreal in the first place in 2021.
Yep.
Right.
Let's see. Somebody was generally asking if RTX DI worked with sequencer. So how you were animating objects in your scene. Was that done? How are you importing those animations or using them?
So for RTX DI or GI? Sorry, I missed the beginning of the question.
The question was around RTX DI, but I guess
Okay.
either or.
Yeah. So basically, like in terms of workflow, nothing like RTX DI doesn't really affect or require any additional content preparation or restrictions on how you import your content or animations. In my particular scene, you might notice that I'm animating everything through blueprints because that's how I prefer to do things. But if you want to do it through sequencer or import it from an external application or use a control rig, that is all totally fine. What RTX DI is enabling you fundamentally is basically to be able to render or process a huge number of lights instead of tens, or hundreds. You're dealing with thousands of lights in a very efficient way.
Yeah.
Awesome. I want your carnival to be a real place. It looks so nice.
Yeah, it looks cool.
Let's see. I think those are our core questions today. I do want to say to the community, I know you all have already volunteered yourselves that it's like, if you have additional questions that we didn't get to on stream today, please feel free to toss them on the forum thread for the stream announcement, and we're happy to follow up on some questions and dig in a little bit there. So
yeah, sure.
Yeah, absolutely.
Yeah, please toss extra questions in, and we'll help follow up with you all. But are there any additional items or things you want to leave the community with today?
I think if we shared some of the links about additional resources for both RTX
I can see them getting linked in the chat.
Cool. Yeah, that's what I'm just asking for.
That's really it for me too. Like, yeah, as long as we can share those out and people can see where they can go to learn more about it, then that's I think the best thing. And Homam and I and other people at NVIDIA will be paying attention to any questions people have in the chat or the forums and so forth. Because we're very interested in seeing this technology improve and grow and make sure it does what people need it to do. So we're taking it all in.
Awesome. Yeah, and we've dropped them throughout the show. I know Sky's adding them to the chat as we speak, and we'll make sure to drop all of these links into the forum post themselves so you all can follow up. I know we're all really excited to see that jungle scene come to your showcase, so
Yep.
definitely keep a lookout for that. That was really beautiful and will be something worth digging in and playing with. And then, yeah, once we get to a place where we can
Cool.
show and talk about any plugins around UE5 and how all those interact, we'll have to regroup because it's some exciting
definitely.
development.
Right. Yeah. Because for sure, there's going to be some follow up there in the future. Like yeah, our team seems to keep growing, so we're a lot of active Unreal Engine development is happening.
Awesome. Well, thank you both for showing up today. Again, lots of really, really impressive content. Community, if you have questions, please toss them in the forum post that we've linked and check out all the resources. There's a lot of cool materials there. Also, another warm welcome to Tina. We're excited to have her here and join us on the team and in the family. For all of you that are following at home, follow us on our social channels. It's insert social channel / or at Unreal Engine, whether that's Twitter, Instagram, Facebook. You can keep up to date on all the latest news and happenings around the community. If you're streaming on Twitch, tag it with Unreal Engine. We want to see what you're doing, follow your development, and see all your cool projects. If you have anything you want to include in our countdown, you've seen some of our videos at the very beginning of the stream. Take 30 minutes of dev time, condense it down into 5 minutes. Let us know, your team name or your project name, any of that information that you have available, and send it to us at community@unrealengine.com, and we'd love to check it out. So, yeah, that's it for this week. We're, again, grateful for all of you to join us here, the folks at home. We hope you have an absolutely wonderful week, and we will see you next Thursday. So, bye all.
Bye.
Bye. Thanks. Bye.
Thank you.